Today we'll be doing acids and bases. The standard level part of acids and bases is actually very, very simple. So first you have to introduce to the students two types of acids and bases or the definitions of acids and bases that they need to know. One is Bronsted-Lowry acid and bases, and the other one is by Lewis definition of Lewis acids and bases. So for Bronsted-Lowry acid is a species that donates proton, while base is a species that accepts proton, while Lewis acid is a species that accepts a lone pair of electrons, and base is the one that donates a lone pair of electrons. Okay, so then you also need to explain that all Bronsted-Lowry acids and bases are actually a subset of Lewis acids and bases. Okay, and could show a reaction of Bronsted-Lowry acids and bases with water, or with any Bronsted-Lowry reactions. For example, you can put HCl plus water, giving you H3O plus and Cl minus. Here you need to introduce your students the concept of conjugates. Okay, so for example, you know that in this reaction, HCl is acting as an acid because it will donate a proton to H2O, producing this H3O plus. Okay, which means here HCl is the acid and water is the base. Okay, and after an acid donates a H plus or proton, it will become a conjugate base, and this is conjugate acid. Okay, if you are asked to define a conjugate acid-base pair, okay, this refers to a pair of species differing by H plus. Okay, so which means in this reaction, if you are asked to identify two conjugate acid-base pairs, you can say it's HCl and Cl minus. This is one pair, and another pair will be H2O and H3O plus. Okay, this should be something new to your students, so yeah, you can just let them know. And you need to, the students need to be able to identify, if they write something like this, there is a reaction of acids and base, they need to be able to identify whether it's a Bronsted-Lowry reaction or Lewis acid-base reaction. Okay, they also need to be able to give examples of each. Generally, any normal acid-base reaction will belong to Bronsted-Lowry and Lewis acid. So there are two types of reactions that are an example of a Lewis acid-base reaction. Okay, only, which is not Bronsted-Lowry acid-base. Okay, so one is a reaction between NH3 and BF3 to give you NH3BF3. In this case, okay, N will donate the lone pair to B, giving you NH3BF3. So in this case, NH3 is your base and BF3 is your acid. Okay, the second one is you have to remind your students about this. This is a complex formation. They should have learned this, especially if they're in higher level. If in standard level, you probably have to explain a little more because they don't learn complex formation in chapter 3. Okay, chapter 3 HL. Okay, this is where you have a central metal ion and you add ligands, for example, and you'll form a complex. Okay, in this case you have Cu2 plus, and the ligand will donate a lone pair to the metal ion. So in this case, your metal ion is the acid and the ligand is the base. Okay, so these two are specific examples of Lewis acid-base reaction, which are not Bronsted-Lowry acid-base reaction. Okay. Now for the properties of acids and bases, you need to explain to them the properties in aqueous solution. Okay, so for example, their solubility, and certain bases are soluble, certain bases are not soluble, and the soluble ones are called alkali. And you need also to explain about the pH. For example, acids. Okay, this one is only for Sl. So we can say that pH of acid is less than 7. And for base is greater than 7. But later we will learn in the HL part that 7 is only for 25 degrees Celsius. Okay, so for SL this is sufficient. And then you need to tell them about the color of indicators when acid is added or base is added. Okay, and the last one is reactions. This one they should have learned it. Well, actually, this part they should have learned it in earlier studies like O levels or IGCSE. So reactions, you need to mention acid plus metal, acid plus carbonates, and acid plus base. Okay, they should know the product. Salt, hydrogen, salt, water, carbon dioxide, salt, and water. Okay, so that's all about properties of acids and bases. In the next part, strong and weak acids and bases, you need to define strong and weak. Okay, so you need to emphasize that whether an acid is strong, an acid or base is strong or weak, it depends on the extent of dissociation. And also explain how this is often confused with concentration. Okay, so a weak acid can be very concentrated and have a very low pH, but it is still a weak acid. Okay, so you need to explain that to your student. Okay, it's all about extent of dissociation, and you need to be the students need to know how to distinguish them. Okay, so they need to know how to distinguish a strong acid and a weak acid. But one thing that you have to emphasize before you tell them this is that the strong and the weak acid, before you differentiate them, you need to know that they are of the same concentration. If they are of different concentration, there is no way you can really differentiate them. Okay, so remember, to distinguish a strong acid from a weak acid, you must start with two solutions of the same concentration. So if they are of the same concentration, they'll have difference in three things that they need to know. One is the pH. Okay, so of course weak acid will have a higher pH than a strong acid. Second is electrical conductivity. Okay, and third is rate of reaction. And this rate of reaction can be followed by rate of formation of gas. Okay. So in the third method, we usually react the acid, mainly the acid, with either metal or carbonate so that we can see the formation of hydrogen gas or carbon dioxide. Okay, so we can also say effervescence. A strong acid will have a greater rate of effervescence than a weak acid if they are of the same concentration. Okay, the last one is about the pH scale. You can explain briefly that pH is minus log of the concentration of H plus. Okay, this is not required in the standard level. We can give them an introduction of this and hopefully it will help them in understanding. Okay, so I will usually use this. Negative shows that the relationship is opposite. Okay, which means when pH increases, the concentration will decrease, okay, because of the negative relationship. And when you look at log, okay, they should have learned logarithms in mathematics, so they know that it's about 10 to the power of something, okay. So when the pH increase by 1, the H plus concentration will decrease by 10 times, okay. So when pH decreases by 3, for example, the H plus concentration, first, because this decrease, H plus will increase, and because it's 3 times, it will increase by 10 to the power of 3 because of the logarithm. Also, when this one, in the strong and weak acids and bases, you need to give your students an example of all, okay? Strong acids and weak acids, strong base and weak base. Because when they see an equation, they need to be able to identify what is strong acid and what is weak acid. So generally, for strong acid, there are 3 that they need and should already know. HCl, H2SO4, and HNO3. Okay, then for weak acid, carbonic acid. Okay, then they need to know that anything with COOH will be a weak acid. Okay, and then for strong base, it will be group 1 and group 2 hydroxides. Okay, and for weak base is ammonia and anything with an amine group. Okay, so basically they need to know this and they need to be able to write the equation. So they need to know that when you use a strong acid, okay, reaction with water, very important, it will be a single arrow, it will be straight arrow and the product, okay. But if you're using a weak acid reaction with water, you know it will be a reversible arrow because the dissociation is not complete and the